Hello guys, this is Surendra and we are going to continue the digital lecture series. So in last lecture we have discussed the D flip-flop and T flip-flop. So now what I said in last lecture that we will study the uses of characteristic table. So now let us see what is the uses of characteristic table, and we will see some use how to implement the different flip-flop using different flip-flop. So guys, this is the excitation table of all the flip-flops, and this is SR flip-flop, this is JK flip-flop, this is T flip-flop, and this is D flip-flop. We have studied all the four flip-flop. So now what I am going to tell you that how to converse one flip-flop using other flip-flop. So let us see how we will go through the. We have some step. We have to follow that step. So how we have to go, we will discuss. Suppose guys, we have SR flip flop and we have to convert into JK flip flop. We have seen that what we have done. We have converted that SR flip flop into JK flip flop. Now we will see how to convert by these excitation using excitation table and characteristic table. So I'm going. I'm going to give this example, and I will give the example of T flip flop as well, and other flip flop I will give as a homework. And if you have any doubt, so you can comment on comment section, and I will make the other video on that flip flop also. So in last video, because of some problem, I didn't have shown equation of excitation table. So this is the equation of this is the characteristic equation, and I didn't have made it the excitation table. So this is the excitation table. You can made by own also. If you have any problem, then you can ask in comment section. So guys, this is SR to JK flip flop. So what we have to do, we have to make the characteristic table of JK flip flop, and then on the basis of Qn and Qn plus 1, we will make the table with the help of this excitation table, and we will solve by K-map, and whatever K-map equation will come, that we have to make that circuitry, and that will be JK flip flop. So let us start. First, what we have to do? First we have to do. First we have to do the make the characteristic table. Make the characteristic table of required flip flop. Like here we need JK flip flop. SR to JK flip flop. So we need JK flip flop. So we will make the characteristic table of JK flip flop. And what is the second step? On the basis of Qn and Qn plus 1, we will make whatever flip flop we have, we will make the excitation table of that flip flop. So we will got some characteristic table. On the basis of Qn and Qn plus 1, we will make this excitation table, and then we will solve that whatever we have done previously. We will solve this thing and this thing, and that will go to the conclusion how that circuitry will implement. So first I will start with the characteristic table of JK flip flop. We already have done this thing, so I'm not going to teach you step by step. I will just write the characteristic table. So guys, when the input is J and K input is 0 0, then the value is Qn only. So 0 0 0 1. When the input is 0 1, then the value will be 0 0. That will not be depend on this one. And when the input is 1 0, the value of Qn plus 1 will be 1 1. And when the input is 1 1, then the value will toggle. So 0 become 1, 1 become 0. Now what we have to do, we have to write the characteristic table of S sorry excitation table of SR flip flop. So we already listed over here what is the, like, if Qn is 0 and Qn plus 1 is 0, Qn is 0, Qn plus 1 0, then the S will be 0 and R will be cross, means don't care. S will be 0 and R will be don't care. If the Qn is 1 and Qn plus 1 is 1, so this will be cross and 0. I already have done how to implement how this comes from the characteristic table. So I already have done. If you want to see, then go to the SR flip flop video and watch that video. So if the Qn is 1 and Qn plus 1 is 1, so that will be cross and 0. So cross and 0. So guys, with the help of that table, I have made it this characteristic table of SR flip-flop. Now what we have to do? Now we have to do like we have to solve this by K map, and then we have to come to the conclusion. So we will put into the K map, and we will solve by. So this is for S, so 0, and then cross. Then this is at fourth position, this is 1, fifth 0, and sixth 1. This is the kmap for S is equal to, this is uh, so guys, this is like J, K and Qn. So we can solve by, because there is no quad, so we will make pair only. That will be S is equal to J into Qn bar. So S is equal to J into Qn bar. So similarly, we have to do for R also. So R will be, like cross, 0, cross, and 1, and seventh one 1. That will be like this one. So this is nothing but K into Qn. So R is equal to K into Qn. So guys, this is two equation. Now how we have to implement, like suppose suppose this is the S and R flip flop. This is Q and this is Q and bar. So what first equation says? J into Q and bar. So J into, suppose this is one. This is J into Q and bar goes to S, and Qn into K goes to R. Goes to R. So this is nothing but JK flip flop. Same thing we have done in the implementation of JK flip flop. We have just inverted this barring. So this is the only logic behind it. So next thing, next using T flip flop. The implementation of other flip flop using T flip flop I will do in next video. So thank you for watching the video, and if you like the video, please like and subscribe the channel. Thank you.